All right. Well, thank you very much, Nancy. So good evening, everyone. I'm Tom Kabat, and welcome to it's our third session in community collaboration sessions put on by individuals in Menlo Park, trying to help the community grapple with preserving the climate and adapting to the parts that don't preserve. So today's January 19th, 2023, we're recording this. And so we may play it back later, but the reason we wanted to put together a session at this time is that so much has been happening that's making electrification easier. It started out pretty tough, and now it's getting partially easy because of a lot of introduction of some new technologies, some more practice skills in the trades, and more companies coming in to provide services, and much more incentives, especially in San Mateo County. So a lot of the incentives I'll be talking about will apply to all of the cities in San Mateo County, even though this session is put on very specifically for Menlo Park residents and the public to take a look at. I think everything I say will be applicable to all 20 cities and the unincorporated county in San Mateo, but some of the incentives that are available here are different than incentives available elsewhere. So people in other territories may want to look for their own incentives. And see, I'm going to try to start the screen share and do a presentation. I'll probably do about 50 or 60 minutes of presentation, and then we can throw it open for 30 minutes of questions and answers. If you have questions along the way, you can type them in the chat. And if they are clarifying questions that I need to address at the time, I think one of my co-hosts will be able to pause me and ask that clarifying question. Otherwise, we'll get to all the detailed questions in a kind of a more back and forth discussion at the end. So let me try to share screen. All right. So hopefully you can see the first slide.
Yes.
All right, thanks.
Yep, we can see it.
Okay, so this is put together with a bunch of materials developed by myself and Josie Gaylord, a former Menlo Park Environmental Quality Commissioner. She and I have been partners on a project. We're providing kind of pro bono consulting services to a San Mateo County project looking at electrifying homes and developing plans for that. And in the course of that, we've been collecting a lot of data about what it costs to electrify homes and about what the incentives are and about how to do it at lower costs. And so I'll be sharing some of that. So the agenda today is to really go over what are the electrification basics, why do the electrification, have an example home here that I'll share with you, and talk about really there's ample electric panel space compared to what most people think and why that is. And then we'll talk some about what we call the silver bullets, these devices, certain devices or models or sizes that really help you fit everything onto the existing electric panel, which is one of the ways to save a bunch of money in the process. You don't have to do it that way, but it's good for your own wallet doing it that way. And it's also good for the grid and the climate. Turns out it'll be a bit crowded on the neighborhood grid if we kind of get sloppy in how we electrify. But if we are thoughtful about it and put in the right size devices and good efficiencies, we'll be able to fit more of us onto the neighborhood grid before PG&E has to come out and upsize the transformers and things like that. Otherwise, we might have a kind of a neighborhood grid traffic jam in a few years if we aren't kind of careful and thoughtful about it. We'll talk about new, easier devices that have come into the marketplace, about how to make an electrification plan, about what these electrification incentives are, and to what extent does timing matter. And then we'll get into those Q&A parts. But on the topic of why electrify, PCE, which stands for Peninsula Clean Energy. They're the joint powers agency made up of all the cities and the county in San Mateo County. Together, that public entity provides 100% carbon-free electricity already today. So they're the portfolio manager that goes and gets the electricity that is provided across the PG&E wires in the county to our homes. So we already have carbon-free electricity, and it's a great stepping stone. It's a clean, green stepping stone to move into getting rid of the chemical energy delivered to our houses and the chemical energy we go to the gas station to pick up. So this clean electricity really enables that quick transition away from fossil fuels. And then we really have to electrify if we're going to meet all our needs with clean renewables. We can't really meet our needs with clean renewables without electrifying, pretty much everything on the ground. So that's just the way the physics are working out. The nice thing is going that route produces cleaner air, both indoors and outdoors. It also saves energy because electric devices, especially these heat pumps, are 3 or 4 times as efficient as anything else out there. And induction cooking is twice as efficient as old electric coil cooking that everyone thinks of when we say electric cooking. These things save energy, they improve health, and they improve safety around the home. So it can also save costs and hardship later from climate damage, because right now we're kind of laying up a whole lot of carbon pollution into the atmosphere and not paying for it, but we're leaving kind of a tremendous burden for future generations to pay for. Electrifying is a step we can take here in San Mateo County to decrease that damage. And then also, we are right now in a bizarre gas rate surge on the West Coast. And I'm kind of tracking what I think gas rates will be in PG&E's next rate release in February. They're at a pretty high record right now, over almost $2.50, depending on which tier you're in. And I think they may be headed to $4 in February, but we'll see more from PG&E in the weeks to come about that. Maybe they've hedged better than I thought. Okay, so what is this building electrification I'm talking about? It's basically replacing the major fossil fuel users in the house. So replacing the gas furnace, the gas dryer, the gas range, the gas water heater, and doing home car charging so you can replace gasoline for the car propulsion. And so we tried to really focus on using high efficiency electric alternatives to do that, not just old electric resistance coils that everyone thinks of when they first think of electrification without knowing about the new efficient technologies. And then also lots of people who do this like to combine rooftop solar because it's a cheap source of energy to help reduce their total utility bill. And also it gives them a chance to pursue home batteries, or coming out very soon now is two-way vehicle to home charging, where you can charge your vehicle from your home, and in outages, you can charge your home from your vehicle. That kind of technology is just coming out onto the market now, but things keep improving. So these are the major 5 end uses I'll be talking about. End use means providing thermal comfort, like from a gas furnace, or providing clothes drying from a clothes dryer. So part of this, I'll talk about an example home. It was 1,900 square feet with 4 people. They had a 100 amp electric panel, and 100 amp electric panels used to be pretty common in homes built up into about 1970. And since then, they've been using more 200 amp panels when they build them. And an amp is short for ampere of electricity. It's an amount of current that flows, and 100 amps of current is enough to provide 24 kilowatts of power. And so we're familiar with power, like from a 60 watt bulb, that's the watts are the power, or a 100 watt bulb. But 24 kilowatts is 24,000 watts, so enough to run 240 100 amp bulbs. So anyway, I'll talk about amps sometimes and watts sometimes, but amps are current flow, watts are power, and they're in proportion to each other. So Josie and I kind of developed this diagram on the right in kind of in cooperation with a local artist, Courtney Breyer. And so this kind of diagram is showing a completed electric plan just drawn into the form of a panel diagram with the switches shown in the center and labeled, and then the device amps and the device volts out here in numbers to the sides. But it was a way to organize information and help us check to see if we could load all the devices we want, including car charging and solar, onto a 100 amp electric panel. And in this case, for a 2,000 square foot home, we were able to do it without using any special controls. And it came out to 96 amps, the way the National Electric Code, NEC, we call that, scores all these devices. So the code is trying to keep you from overloading your panel so that you won't have these nuisance panel trips, which are extremely rare. I've only heard of one rumor of somebody tripping their main panel by overloading it. So up here, I'm circling where the main breaker is on a typical panel up at the top. And so if you put really high loads on most of this stuff and it didn't trip those breakers, it could trip the main one. And that's a safety device that's there to protect the panel from overheating and to protect the service wires, those wires that come from the pole or come underground to get to your meter. All right. Some of the things we've been doing, we study this with different groups. We've got, from our little study with the county, the 10 homes that we're looking at on the left, and these are in 10 different cities in the county, and then Josie's and my homes on the right, and I've kind of forgotten now whose is whose, but the blue part of this graph at the bottom is the highest amount of electrical capacity used in the past 12 months for any of those homes. And the green part above it is the unused part of the electric capacity of the panel. And so you can kind of see by these that even when people are, when they're first starting over here on the left, they have lots of unused panel space that they can electrify into. And then Josie's and my homes now have gone to all electric. And I think for each of us, the blue bars are maybe up another quarter inch or something, but we've still got more than half of our 100 amp electric panels still available for more electrification, but we don't need it. Each of us is finished. She's finished her house recently by putting in a heat pump water heater, kind of very similar to the one in this picture. So here's a picture from one of the houses in the study. They started with a 50-gallon gas water heater in the garage. And then we suggested that they upsize from 50 gallons in that 4-person household to 80 luxurious gallons of water. So it gives them more and more morning showers without running low on hot water. And then to have it be reheated with a 15 amp version of the heat pump water heater. So that the heat pump, when we talk about a heat pump water heater, the heat pump is this part on top of the water storage tank. So the water storage tank is the bottom 3/4, and the top 1/4 is the heat pump. It's really kind of like a backwards refrigerator compressor. And you know how your refrigerator is taking heat out of the freezer at about 0 or 5 degrees Fahrenheit and jacking that heat up to about 80 to 100 degrees Fahrenheit by using the compressor to compress the refrigerant, which gets hot then when you compress it, and then it blows the heat out across your toes. You feel it in warm air blowing out from under the refrigerator sometimes when it's running. So a heat pump water heater is just got the same kind of a compressor. It's roughly twice as powerful as a fridge, but it's running the other direction, and it's grabbing heat out of the garage, raising it to a nice hot temperature, and then heating the water up to 120, 130, 140 Fahrenheit. And so that's how those work. And we tended to recommend these 15 amp versions, which they just use smaller electric resistance elements. These two little warts you see on the side of the heat pump water heater are backup resistance elements. When the heat pump's running, it's only taking 4 or 5 amps of power to run, but when the backup resistors run, they take 15 amps. The other thing we look at in these houses is, can we convert from their gas furnace? In this house, they had a gas furnace in a closet inside and an air conditioner compressor outside, and convert that over to one machine that does both tasks. So it'll have this suitcase shaped thing outside, replacing that box on the far left. And then this kind of dark gray air handler replacing that light gray furnace. But it's got the internal fan and fan coils in it. And so it either heats or cools the air. It does both things. So it's good in both seasons. And in this case, we were recommending a very efficient 3-ton inverter-driven heat pump. And our inverters are computer-controlled devices that control the amount of current and voltage arriving to the motor, to change the power of the motor, to change the speed of the motor, to change the amount of the power rating of the work it's doing. So the nice thing about these inverter-driven heat pumps is they will cruise down to the equilibrium power needed to keep your house at your set point. So they won't be running super powerful and then shoot past your set point and then turn off and slam off like your furnace and coast and leave you kind of in the cold, or leaving your house kind of declining in temperature, and then they rocket on again and climb. That's what your furnace does, but these inverter-driven heat pumps, they kind of get steady and they just kind of oscillate right at the set point. In the cooking side, this house had a very big, luxurious, expensive gas range, and we found a very big induction range that could replace it as a slide-in device. And then they also had a resistance electric dryer. But when we were trying the experiment of, can we fit everything into the house on the 100 amp electric panel? And one of the ways we were able to do that was to replace the electric resistance dryer with an electric heat pump dryer. And the heat pump dryer, again, uses that backwards refrigeration cycle, but it uses it to condense the water out of the wet air that's circulating around the clothes. So the clothes are tumbling in the dryer's blowing warm, dry air across them. That becomes warm, wet air. And then the heat pump condenses the moisture, the liquid water, out of that warm, wet air. So it goes back as hot, dry air, and then it goes and picks up some more moisture from the clothing. So that was one of the devices we tended to recommend. There's another one that I use in my house that I like for really saving extra power. It's a 4.5 cubic foot, 120 volt plug in the wall, all in one machine, where I put dry, dirty clothes into it and just set it for 2 or 3 hours, whatever timing I want to pick based on the load. And then I come back and I get dry, clean clothes out of it. And so it helps saving me from that problem where I might forget and leave damp clothes in the washing machine when I went off and did something else. So it's kind of a neat thing. Also saves about $10,000 worth of floor space. And I kind of like it. For EV charging, we found that it made sense to be recommending people pick these adjustable EV chargers, like on the left. This one was one that can adjust. It has switches, dip switches inside it, so it gets set by the installer to be any level of current flow between 6 and 32 amps. And so that can help it fit on the panel. So we might design everything else in the house for the different sizes people wanted, and then look to see how much leftover amperage is left on the panel. Okay, let's allocate all of it to the car charger. So then you get approval to do all of the electrification with the charger set at that level, and no special controls on the charger. The other way to go is off here on the right side, which is just to put in a smaller amperage plug. And they make these different sized plugs that kind of top out at different amperage levels. This one was a 12 amp, 240 volt plug. Well, if you want more power for car charging, one of the ways you can go is to start adding circuit sharing or automatic load pausing controls when needed. So some houses, actually one house only had a 60 amp panel, but it was a 2.5-story house. And so in that case, it looked like, oh, this might be a good case to put in one of these smart panels, but it's a $3,000 piece of hardware with another couple $1,000s of installation expense. So they really tend to earn their keep when somebody's trying to stay on their existing electric service line. I mentioned that line that goes from the utility to the house. If your service line is underground in a trench, it's very expensive to dig it up and retrench and put in a bigger one in order to upsize your panel. So sometimes a panel like this can really let you live quite large on the old small service wire. And then here are two others, smaller, subtler, cheaper ways to go about it. This one called DCC9 is one that pauses the car charger when the load on the regular dumb panel was up over 80% of the rating. So as soon as it got over 80% of its allowed load, got to 82% or something, it would cut the charger out of the supply so that then the load dropped back down. And then it checks back every 15 minutes to see, essentially it's checking to see, are you done cooking on that giant range yet? But if it sees the loads are down, then it will reinitiate the car charging. It probably doesn't kick on very much for people who charge their cars after 11 or 12 when the rates are down again. So anyway, that's one way to do it. Another is they make devices that allow sharing between two things. So we call them circuit sharers. And so one side might be, you might plug the dryer into one side and say the dryer gets priority, and plug the electric vehicle into the other side, and then plug both, plug the whole thing into the old dryer outlet. And then whenever you want to dry clothes, the dryer gets priority. And when the dryer is done, the car charging can automatically restart. So that's what we mean when we were talking about circuit sharing and pausing, which are two slightly different functions. In this house too, since we were looking at that 100 amp puzzle, we suggested that they use the largest size solar system and battery system that can fit on a 100 amp panel according to the electric code. And that works out to be about 5.8 kilowatts of solar, kind of trimmed down through an inverter and then backfed onto the panel through a 20 amp breaker. And so that's a route that they could go, or they could also use the solar tax credit, which is now 30% of the cost of putting in solar and batteries, and anything associated with getting the solar in, like new roofing and electric panel upsizing to accommodate the solar. So some people choose to use their solar adventure as a chance to upsize their electric panel with a 30% tax credit. In this house too, we were looking at different building shell improvements with those heat pumps. They're kind of, they have a slower, steadier thermal power, and they aren't quite like an oversized rocket like a lot of our gas furnaces. So it's nice to put in more insulation. And also, since electricity is a relatively expensive fuel, the heat pumps are very efficient. They're using 1 unit of electricity to go gather another 3 units of heat from the yard and put all 4 units of heat into the house. So they can have a 300 or 400% efficiency compared to the thing we think of when we talk about electric heating. We think of those electric resistant space heaters, which are only 100% efficient. They just heat up the wire and your house gets all the heat from the wire. But because they're just a toaster and a fan combined, whereas the heat pump is this great heat moving machine. It's like I said, it's a backwards refrigerator. It will go grab heat out of the yard and jack that heat up to 120 degrees and use it to heat a coil, blow the room air across the coil, heat that air up and blow that into the room. Okay, so in this house though, they only had about R19, about 6 inches of insulation. We recommended they double that, and that would make it more affordable and comfortable. In the crawl space, It didn't have any insulation. We recommended they consider going up to R19, but crawl spaces, it's a little bit hard to really save much energy there. I've heard it does produce some more comfort, but it's hard to find the energy savings because the heat doesn't really travel down that much. So it's not always an important item. Okay, so I wanted to mention some of these silver bullet technologies. What were the things we found that are making it easier and that we tend to recommend? And so they are things like the 15 amp version of heat pump water heaters, and also the new 120 volt plug-in versions. And I just had the pleasure of installing one of those with a nonprofit I volunteer with. And the 120 volt one is, boy, it's a lot closer to a washing machine in a way, because it has all the same connections a washing machine has. It has a hot line and a cold line for water, and it has a 120 volt plug. And then it has a line that wants to drain a little bit of water too. So same as my washing machine has. Anyway, we really like those 15 amp versions of the heat pump water heaters or the new 120 volt versions. If you have a sheltered place to put it, like a garage that stays above 40 degrees Fahrenheit, the 120 volts can work there. If you've got a place that's going to drop for long periods below 40 degrees Fahrenheit, then maybe the 15 amp one works better. We also ended up recommending frequently these types of inverter-driven heat pumps that were about 17 amps of power load on the panel to provide what we call 3 tons. That's 36,000 BTUs per hour of heat. They tend to be very power efficient and quiet. So that was one of the nice things about these inverter-driven ones. Also, some of the ones we were proposing don't need a second circuit for the air handler, that gray box I was showing you. They feed that gray box off of an umbilical line coming from the outdoor unit, so alongside the refrigerant line sets. So that was one of those centrally ducted heat pumps with an air handler on the same circuit. So that's what I was describing, with it kind of fed by an umbilical cord. The other thing I kind of like in some cases are multi-zone ductless heat pumps. So those are the ones that have that little thing. It looks like a car bumper up on the wall is the most common one that I see. And those can be a real problem solver in some cases. The other thing we recommend is upsizing the water heater tank. And so you saw that where we were recommending they go up a size, or even in their case, 2 sizes at that home. And even adding a mixing valve to the plumbing that is a thermostatic mixing valve that lets you set the water heater at an even higher temperature, maybe up around 135, 140 Fahrenheit. And then it mixes a little bit of cold water as needed into that hot water to deliver a nice safe 120 degrees or whatever you dial it to. But that way you get to store extra energy in the tank as a big thermal battery and then dispense it at a safe temperature of 120. Okay, other things we like to look at are in one of the houses, they needed a split heat pump water heater. And so it had an outdoor compressor unit, kind of like the space heat pump. And then that outdoor unit pumped hot water over to a storage tank. We had to do that in one house because the space it was in an underfloor space that wouldn't allow a tall tank. And so we went that direction. We also like heat pump clothes dryers or the combined washer dryer, all in one machine. And then these adjustable EV chargers so that you can adjust them for the remaining power you have. Or another one I've heard of, a friend of mine has told me about this Emporia smart charger, which uses its own sensors on the main electric panel to sense when the panel is getting up to that 80% limit, and then it pauses itself. So it that charger has combined kind of one of those gray boxes I was showing that was the controller. It's combined that controller with the car charger itself. So we also like these circuit sharing devices you can plug in yourself. Some of the brands are NeoCharge, and Dryer Buddy is another brand. It plugs into the dryer outlet. They all do. And then you plug the dryer in one side and the car in the other. And Simple Switch is a company name that makes some of those, and another one called Split Volt. So I guess there are now 4 of these companies providing circuit sharing devices. Then we like those circuit pausing devices, like I showed you that DCC9 gray box. There's a couple other brands, EV Duty, and then Simple Switch makes another product called 240M. M would be for its metering the panel, so it knows when to pause. And then I also showed you that smart panel like span.io, or sometimes you can get by with just one smart breaker or that smart charger solving the problem. So now they're coming all these interesting 120 volt, just plug in the regular outlet. So you don't need an electrician for the things on this page. So there are heat pump water heaters like the one I got to install the other day. The Rheem is the first one on the market making them. Others are coming soon. Rheem has 2 models. One of them would need its own dedicated circuit. The one we installed the other day could go and share a circuit with other devices. It's only using about 400 or 500 watts on a circuit that can easily deliver 1500 watts. So there's room for other things on the circuit. The one that needs a dedicated circuit had 2 compressors in it, and so it was using more of the circuit. They didn't want to risk putting other stuff on there that would trip the circuit and leave the person without hot water. So I told you, I really like this kind of 4.3, 4.5 cubic foot combined washer dryer machine, but that's not for everyone. Some people want to have 2 different machines to manage. And so for those, they make nice heat pump washers. Let's see, I don't have that on the list here, but let's see, who is it? I think Whirlpool makes a great 7 cubic foot heat pump clothes dryer. And then we like packaged heat pumps. So they have this funny initials, packaged terminal heat pumps. There's one from a company, I think they're called Ifoca, and they are very quiet. And you drill holes through your wall to mount that thing in the room. But there's also now a couple of portable inverter-driven heat pumps. A new one I just heard about the other day is from a company called Cooper and Hunter, and then one I've helped install elsewhere on people's homes temporarily is the Medea brand. Both of these portable in-the-room heat pumps, they have a dual hose setup that gets air from the outside and takes heat out of it and then puts the cold air back outside. And they work down to about 40 degrees Fahrenheit outside. And these brands with the inverters are quieter than the others. They're not super quiet because they're in the room with you, but they're pretty good. And they're kind of an interesting energy saving solution that even renters can use because you can move it from place to place. There's something coming to the market from a company called Gradient is a cold climate window heat pump. So it's a window air conditioner that can go both ways, heat and cool. I have a Frigidaire window heat pump upstairs in my house, and it's still working well, but it cuts out at about 40 Fahrenheit. So when it gets down that cold, we open up open up a door to downstairs to let some more of the downstairs heat go up, or use the resistance heater. And then other good things we were finding are seen that are coming to the market. There's a 4-burner induction battery powered cooktop. So it's got both 120 volt and a battery inside it. And so it's from a company called Impulse. It's on its way to market. And then there's a 4-burner battery range, and range means it's got the cooking hobs on top, 4 burners, and then an oven under it. And so that's out on the market right now by a company called Channing Copper. So there's lots of these interesting plug in the wall. You don't need an electrician. They're kind of portable to very portable, except the water heater, not portable. But lots of interesting different 120 volt solutions arriving. Oops. Okay. So but that made me think of Car and Dryer magazine. So that would be the magazine for those plug-in circuit sharers that go in the in the dryer's electric outlet. And so there are a few of those brands I mentioned: Dryer Buddy, NeoCharge, Split Volt, and Simple Switch. Those only take a minute to install. They cost around $300. And so they're really easy for you to do. And now there's something called smart power cords for charging your car. So it's taking what is a smart on the wall car charger smartness and putting it into that portable charger that may come in your electric vehicle trunk. So you might look for smart EV cords. So now I want to talk a little bit, I've gone over a lot of products so far. And then I thought we'll talk a little bit about some information sources that are increasing. And so there's more of us doing these things and putting out materials and providing advice. And there's a few different concierge services opening up where you can go to these companies and get advice for how to do your electrification, how to make a whole electrification plan. One of the things I like to help out with is the Ask Sean show. And it's put on by a group down in 350 San Diego, and they bring in Sean Armstrong, and then I help out some. But it's a call-in advice show about home retrofits, and it's the second Wednesday of each month at 7 p.m. So you might look them up. And then there's 3 concierge firms listed here that are operating in the Bay Area: Emerald Eco, Quit Carbon, and Block Power. And so they've got links to those. And then Peninsula Clean Energy offers its own electrification advice, and along with offering rebates. And so you might go to their site and see about that advice, because I think they're providing free assistance for folks trying to figure out how to do their electrification. There's also a home electrifiers group on Nextdoor, and that was started by Josie Gaylord. And in that group, we have about now 100, almost 180 participants, and it's people sharing their advice, their ideas, and their stories, and their questions about how to electrify. So it's a peer-to-peer advice group for how to get your projects done. And so it doesn't talk about policy there, but it does talk about how to get the work done. Then the next one down is energystar.gov. So that's the federal government's site, and they've done their own site on their own tax credits. Yay, they probably understand them better than me. And so they've got things like their tax credit site, their installer finder, and rebate finder. So check out energystar.gov. And then my friend Josie and her son Kenny worked with a lot of the information that I was sharing with them about the ways to go about doing this stuff on spreadsheets. Where I started as an engineer, old guy, I just do everything on spreadsheets, but they've been converting things over to kind of more of a web app. That they show a link here for their zero carbon home application, and it's a place where you can go in and list information about your house and your appliances, and post pictures in your own little account to build your own plan online, and it does a lot of the calculations for you. Well, okay, so the case for electrification is getting easier. Basically, we have all the technologies we need, and really it's these heat pumps that are 300, 400% efficient, and induction cooktops that are twice as efficient as gas or the old electric resistance or radiant cooktops, twice as efficient. They boil water much faster, they're controllable. I really love mine. Then also we've got EVs that are great performers nowadays, and we're getting more automatic controls of things. And so the controls can help us fit more things together and play electric panel Tetris a little bit better. So we also have the right ideas now for design selection and sizing and controls. So doing this panel optimization so we don't always have to upsize. And you have to be a little bit careful, because when you bring your first electrician over to the house, they can make more money by taking you down an upsizing adventure. When like you could see from that early chart I showed, we're not really using much of our panels anyway. And even those of us who have electrified carefully, we're still not using that much of our panel. So we don't need to be sold a big upsizing. And anyway, these electric devices are great. They're delivering better performance. They're delivering more family health and safety. So they're cutting out indoor air pollutants and they're reducing burn hazards in the home. And so incentives may be peaking now in the high income sector, and next year they may be hitting peak incentive for medium and low income folks. And that's just my theory that the entities who offer incentives eventually need to rein them in, as we saw with solar. They started the incentives very large when we needed large incentives to make solar economic, and they had a schedule for how to reduce them over time. And so they've been reducing them. You may not even remember some of the ones we used to have. But anyway, so we may be at peak incentive now. And then the financing we can get in San Mateo County from Peninsula Clean Energy is great. PCE is offering zero interest financing for up to 10 years and up to $10,000. The other thing is I showed you concierge assistance is now available from different sources. And you could also phase in your electrification by starting with 120 volt plug-in stuff now, trying it out for a while, waiting for the market around you to change for all the bigger, fancier hardwired stuff if you want, and then later sell your used 120 volt stuff to someone else and get the pros to do your own home in phase 2. And also the cities have started streamlining the electrification process, or the electrification permit process, to help meet their own climate goals. But that's going to take a lot of assistance and encouragement from citizens and residents. I think we need to work with our cities and with our staffs to help them understand the need for streamlined permit processes and the need, to be able to make this simple so we can pursue that macro safety. Anyway, there's lots of, there have been improvements in these 8 areas, and there'll be probably some more in the next 12 months. We'll see how that goes, but it's really kind of a mistake to let things burn out and force you into a corner. So I'll talk in a little bit about making a plan and being ready. Among information resources, there's some excellent guides. And so Menlo Spark sponsored a number of guides. Menlo Spark is a local nonprofit encouraging cities to help meet their climate goals. And so Menlo Spark helped sponsor this free guide, about a 98-page book, pocket guide to how to electrify and retrofit your home. And they also have an electric panel calculator tool online too that you can use and download. So Josie and I were finding a number of things out in that county study and realizing, there's some pitfalls to avoid. And then in green text, there's some solutions to lean towards. So one of the problems was power hog devices, like having that residual range anxiety and letting your electrician sell you the 50 amp EV charger and a panel upsize associated with it, when a 20 amp charger, a 20 amp circuit breaker flowing 16 amps to the car is enough at 8 hours a night to do 40,000 miles a year of driving. So, one could argue that right sizing this will help us all it'll help more of us electrify, because 2 of these folks take up as much pole top transformer as 5 of these folks. So it kind of makes sense, if you want to do something for the climate, is to be sure to right size your devices. And then you want to kind of avoid painting yourself into some expensive corner that requires a panel upsize by picking the first sloppy big thing that somebody proposes without having an electric plan for your home. So the advice here, the solution is make the plan. And then some of those concierge services will help you do that. And so will Josie's online app. And then another pitfall is this thing we naturally have done in the past. We wait for our water heater to fail. And that puts us into an emergency situation. And so you have to take whatever the plumber has on the truck if it's the water heater. And my wife has mentioned that is the device in our home that needs to not be out of service. She said that we could go a couple of weeks without a furnace or a dryer or even a cooktop because we've got other ways to cook and we could always go out to dinner. But it's not as appealing to go out for showers. So my thought about water heaters is quit stalling, replace it now. If you want to gamble, you could just pre-wire for electrification and hope for the best when it finally fails. But it's probably a better idea, I think, to make a plan and then get to replacing that water heater before it burns out. The other pitfall is so many people, especially the HVAC salesmen, heating, ventilation, and air conditioning, so the furnace salesmen, they oversize equipment just to be safe, so that they don't ever get complaints. But the nice thing about heat pumps is they'll work better if they're sized smaller because they've got that inverter-driven feature. It's going to run all of the minutes of the hour instead of just 20 minutes of the hour during the peak day, the coldest day of the year. So because it's going to run all of the minutes, we can go down a couple of sizes. And so we're seeing in houses that have maybe a 60,000 BTU furnace that they can get by with a 30,000 BTU heat pump. And it would operate at full rating. So maybe we know from looking at their gas use data on a daily basis, we can tell, oh, it would operate for about 12 hours a day and deliver all the heat that their oversized furnace used to deliver. So it could do that in 12 hours. Well, if you ran it at that full rating all 24 hours, it would deliver twice as much heat as they used in the coldest day last year. So we recommend being careful not to oversize equipment. Try to go down 2 sizes in your heat pump sizing. And then the next thing is the flip side. Don't undersize your heat pump water heater tank. Go up a size in the tank. So you've got, because the nice thing is the tank's not losing much energy because it doesn't have that uninsulated empty smokestack up the middle of it like your gas water heater has. That's just always got hot water heating that tube, and there's always a draft of warm air stealing heat from your water heater if it's a gas water heater. With the heat pump water heater, it's all sealed in an insulated tank with no stack running through it. So upsizing doesn't cost you more energy. It just gives you a bigger thermal battery for more rush hour showers. Okay, now I've finally gotten to incentives. So incentives are available from about 5 places in San Mateo County. From it in just the county, Peninsula Clean Energy that serves the whole county, and they provide upfront incentives that can be paid to the contractor, or they can also be paid to do-it-yourselfers. So that's a nice new advancement for folks like me who like to do it ourselves. That those incentives are now able to get to us. There's the 9-county area BayREN group, and that is a government agency administering some public benefit funds that pays rebates to your contractor, or in some cases, like for dryers and cooktops, they can pay it directly to you. And then there's the federal tax credits, which just started January 1st for most things. They had existed for solar, but now they apply to solar and batteries at 30% levels, and at 30% levels to a number of things. I'll show you a list in a minute, I think. But these tax credits are a direct reduction in your tax bill, or they may come back if you don't have much of a tax bill, they may come back as a federal check. So talk with your tax person about that, since I'm not a tax person, but that'll make good sense. All right, and then there's a state program called TEC. They have rebates paid to the contractor. There will be for heat pump space heating. Those will probably come up in April or so this year. They ran for a short time last year and they were so popular they got oversubscribed, and so now they've been refunded and they'll come back in April. And then the federal IRA has upfront rebates for middle and low income households, and the state will design that program and try to get it out the door in late 23. I think it might be early 2024 when that's available to low and middle income customers. So here's a graph of showing just the 7 ways you can pay for putting in a water heater. And so here's $2,500 is the cost of having a plumber put in a gas water heater. And then if you do your own gas water heater, it's about $1,100. If you don't get a permit, it's maybe $900. If you have a plumber install a heat pump water heater, the net cost is about $1,200 after these incentives. One of the low bid contractors is down here where your cost is 0 after incentives. Same with a do-it-yourself heat pump water heater. It's about 0 in San Mateo County areas and city, San Mateo's full area. It's about 0 for do-it-yourself heat pump water heaters. Oh, what if you're a do-it-yourself outlaw who doesn't get a permit and doesn't get some of the rebates? Well, you still get the federal tax credit. And so your cost might be about $3,000 for all the stuff, the circuit, the equipment to do the new circuit and the heat pump itself, the water heater itself, and all the little ancillary bits. And then it's about $2,000 after the 30% federal tax credit. All right, so I mentioned that there's more incentives for medium and low income customers. So California will likely roll this out in late 23 or early 24. And these incentives will stack onto the other incentives and be applied before the tax credits. The tax credits kind of apply to the amount after all the other incentives. So here's a little graph that I looked up information for San Mateo County about what constitutes low income by household size. So 1-person household, 4-person, 8, 9. So what is low income? So that's the top of this blue bar. And what is medium income? That's the top of this brown bar. And then this golden area is all of us high income customers, high income families. And so, you can maybe take a look at this chart now and think, okay, yeah, if I'm a 3-person household making $150,000, I'm a medium income household. So I want to listen to what the medium income rebates are. And if I'm making $250,000, I'm a high income customer. I want to just look at the tax credits. Then these 2 other lines are just what is the tax liability likely to be paid on those income levels above. Okay, so the federal IRA, state administered upfront rebates that are coming in late 23 or 24 are up to 100% of the purchase cost of buying things like heat pump water heaters with a cap of $1,750. So that's how to read it. What percent, what device, what's the cap of, and that's the cap for the low income customer, and the medium income customer gets half this amount. So anyway, what do we see? Heat pump clothes dryer, get $840 tax credit. Excuse me, upfront incentive, not a tax credit, but an upfront incentive from the state for purchases in what I think will be 2024. And for a new heat pump for heating your home, $8,000 for low income, $4,000 for medium income. And everyone can get the tax credit, which is different than these upfront incentives. All right, so here's one example done before those upfront incentives. So we've got a bid price on this of $4,300 minus the Peninsula Clean Energy $3,000 incentive, minus the Bayren $1,000 incentive. It's before those upfront rebates from the IRA, but the IRA tax credit is still there. It was 30% of $300 and some dollars. It was only $93. And so the net cost was $218. You could do this tomorrow, and you could compare it to the cost to buy a gas water heater, which is $2,500 through a plumber installed, same as this. So it's really brought it down to where it's looking like 1/10 of the cost right now. So that's why I think, oh, we might be in peak rebates. These look a little rich. Here's the same kind of example, although I did this one with the medium income customer getting the upfront IRA incentive in 2024. So let's say they had a contractor bid came in at $15,000. They get the PCE rebate, it's $3,500. another 1,200 from Bayren, and then this upfront IRA incentive is 4,000. The remaining amount was eligible for up to $2,000 at a 30% tax credit, but it was a little bit smaller than that. So 30% of it was only $1,985. So now the net cost was $4,600 for this thing that heats and cools you. So it'll provide air conditioning. So you could compare it down below to just a plain old 80%, a bottom of the line gas furnace installed by a contractor, $4,800, or $9,600 to also add air conditioning. So anyway, we've got something that's for the middle income customer, even below staying with just repeating with gas, and way below getting cooling with it too. So ideas for timing, maybe start right now by making a plan now. So you can fit it all on the panel to save about anywhere from $2,000 to $5,000, and it may be saving 6 months of time waiting for PG&E to do any upsizing thing they have to do if it's something that needs studying from them. So the plan really helps you save both money and time, and also leave more space for other people to electrify so that they can save the climate for your kids. The water heater does seem like the most urgent thing at my house, maybe at yours. So since it's sensitive, I thought I'd move it to the front of the line for what projects to do. And then either put in the circuit to save future time on the water heater, or I really recommend doing the whole water heater and just save the time and money, because this, often contractors they won't give you a discount for you already having the circuit, is one of the things I find when they're bidding. So there may not be much savings for pre-wiring in money. You have to shop around to see if you can find it. It's also, people say you should insulate before the heat pumps. I hear that from other people. I think, why? Don't delay the heat pump. When you need it, put it in, and get around to insulation when you can. And because really we want to avoid delays caused by a sequencing mentality in all kinds of places. So be careful of that if you're sensing you're trying to sequence too many things. Try to size the heat pumps for 3 tons or under, because at 3 tons and under, so 36,000 BTUs per hour and less, they can deliver that heat over the existing ductwork for the old gas system you're replacing. Above 3 tons, and you can't get that amount of heat through those ducts. The air just, hits a wall. It doesn't want to go fast enough to deliver that heat. So really focus on downsizing to the 3 ton and under heat pump. Let's see. Yeah, then other decisions like when to change cooking, that's whenever you want to improve your family's health and breathing. When to change your drying, that's up to you too. When to do an EV charger versus just plug in the wall. You can get about 40 miles a night just plugged into a 110 volt outlet in your garage or carport. So maybe one idea would be to wait for 2-way EV chargers instead of getting a wall battery or something. For solar, the one thing you may want to wait for is to take a look at the condition of your roof. If your roof is new, you can go ahead and do solar right away. If your roof is on its last legs, you really want to do get the roof done either as part of the solar or before the solar. And then I mentioned electrification plans. So a plan really defines, what are the types of machines you want and the features. For example, like 120 volt heat pump water heater. And then the size, like I keep mentioning 3 tons or under on heat pumps, or 65 gallons on a water heater size, things like that. The model names and numbers and maximum amperage levels and associated breaker size. So, you can have your contractor help you figure that stuff out too. And then any controllers, if you're going to be using controllers, you work them into the plan because they leave you with more free space on the panel. And then a list of what are the circuits you're going to need. So you can check to see, do you want to get all the circuits done at once, or do them project by project? And so there was what one of our electrification plans looked like. It had a floor plan and list of equipment on the left and list of circuits on the right. And let's see. So anyway, there's lots of benefits to electrification, but really today's talk is more about what's making it easier these days. So the future probably includes easier permitting if we can get cities to really focus on macro safety and look at, we really have to demonstrate how this, one of the richest counties in the world, can make forward progress on climate if we're going to expect the other counties of the world to also do things in time to save our bacon. So easier permitting with a macro safety focus will really help. There are more technology solutions coming along. So we have enough now and more are coming and they'll get better. There's the medium and low income incentives, which are probably coming along. There are more concierge firms and programs that'll probably start up. California contractors are learning skills and they're catching up with the South. The South has been way ahead of California because in the South, they've had to manage humidity for a long time, heat and humidity. And out here in California, we've had such nice weather that our contractors only know how to install furnaces, except in some cities that have more heat. So that's been a problem for us in San Mateo County, is finding contractors who understand air conditioning and heat pumps enough to want to install them and not just try to talk us out of them. Better resilience solutions are probably coming along, like vehicle to home charging. And then another kind of sad thing that's coming, we saw, you know, the recent atmospheric rivers happening to us, but more climate decay and many associated problems and systemic stresses on civilization are coming because we are kind of late to starting this up. So I think the other thing that'll happen is we should have more appreciation coming for that we got started today instead of waiting. So try to avoid sequencing, you know, because sequencing kind of slows us down, but here's the sequence, you know, you might want to follow to avoid some problems. So start by looking around your home, download and read that retrofit guide I mentioned, or talk to one of those concierge services, or go to those concierge tools that I showed and start making an efficient plan that's right-sized to meet your needs. Not just the biggest thing you can jam on, but right-sizing it will really help everyone do it. And then consider the water heater first to avoid getting stuck in an emergency position where you're stranded with whatever's on the truck. And a lot of people face this problem of they didn't get the heat pump one wasn't in stock because they didn't pre-order it. So pre-order it, you know, start in an orderly manner. And then roll in the rest of the projects in any order, but sized in accordance with your plan's amperage or power allocations. So make the plan first. It tells you how much power to allocate to the different categories of things you're going to do. And it's okay to do insulation after heat pumps. You don't have to do it before, but you might want to count it into your calculation so you have more courage to downsize your heat pump. And you could always add another heat pump later, or you could add more insulation later. So there are things you can do after you live with your system for a while to adjust to whatever you find. And then it's best to have a good roof condition to save about $2,000 in solar system removal and reinstallation labor. If you say only had 5 years left on your roof, but you installed solar and then 5 years later, you have to take it off and put it back on, probably cost $2,000. So thanks so much for sticking with me through the presentation. It's time for question and answers. So perhaps questions showed up in the chat. I was not looking. But I can.
Hey, Tom. Yeah, there have been some questions that have shown up in the chat, but maybe what we can ask everyone to do is please use the raised hand feature, and then we'll call on you in the order and get all your questions answered. The raised hand is under that smiley button. Yeah. All right. It looks like Kathy's first up.
And then I'm going to keep this deck open in case I have to go to a slide to help explain it.
My question is about the logistics of finding an electrician with time to help with this.
Yeah. Here's one problem where I fall short. I'm more of a do-it-yourselfer as opposed to a shopper. so I don't have great advice, but that home electrifiers group on Nextdoor has over 170 members, many of whom have gone through the adventure of finding electricians, and they have electricians they feel comfortable recommending. So you might join that group and put your question out there. Any other questions?
Yeah, John McKenna.
Yeah, thanks, Tom and Nancy. To that contractor question, just thinking about it, would someone like Emerald Eco or Quick Carbon be a resource for contractors as well?
Yeah, definitely. So the concierge services, they're shoppers and coordinators. They will go find that for you. And so they probably lined up a number of electricians under their umbrella.
And then on the IRA, is there any talk of allowing someone to do the work now and take advantage of the incentives when they're published and available?
Yeah, I've been asking that question since immediately after the IRA passed and the webinars started, and so far I haven't had any positive response on that. So I recommend asking the California Energy Commission and let them know there's an interest. I think they may have to do something like set a date. What if they picked a date like June 1st, 2023, and say projects after that will get it, even though they don't stand up their program until December, 6 months later or something. So I recommend leaning on the state about that, because they're the only ones who can decide.
Got it. Thank you.
All right, and the next hand is Coco.
Hey, Tom, excellent presentation. Thank you so much.
Thanks.
Got a multi-part question. The first one of the early slides you had showed a picture of the panel, like a little cartoon of that.
Yep.
And I noticed that, so if I look at the 50 amp second from the bottom on the right, it says device amp is 40. And it seems all of these are about 80%, or maybe I don't understand exactly why, but why aren't those numbers the same?
Right. So let's see. So let me think. It's been a while since we made this. What is the exact reason for device amps? Yeah, so some of them, they make us put in, let's see, bigger wire, but that's not necessarily bigger breaker. I do, for me, it makes sense on the solar one where it's 16 amps flowing in on a 20 amp breaker. That's easy for me to visualize. It's that they are limiting me to a 16 amp output inverter, and I can put it on a 20 amp wire and 20 amp breaker, because if it's the breaker's the next size above the loading, and that's the normal way to design panels and breakers, is you look at the device flow needs and you go to the next breaker size up for what the breaker and wire can handle.
Okay, so you had, no, please go ahead.
Oh, so anyway, it starts from really the nameplate rating, which is that, say on that one, the 40 amp rating on the nameplate of the range. And then you size the wire to accommodate, wire and circuit to accommodate 50 and go from there.
So my second question, and I'm not sure if you're implying this or not, but I've heard that people aren't allowed to put solar panels on their roof because the circuit breaker won't handle it. And what I don't understand is, with the range, you've got electricity going from this panel to the range.
Mm-hmm.
But, or I should say current, right? Because that's really what it is.
Right.
But with the solar, you have current coming to the panel.
Right. Yep. So you're into a complex matter called the 120% rule. And so in this 100 amp example, we've got 100 amps coming in down from the utility and up to 20 amps or 16, but the breaker is 20 and the code says use the breaker size. So we'll call it 20 amps coming from the solar. So together, there are 120 amps of power available in the panel. And so the code lets you go over 100 amps for the combined amount of those two, but not over 120% of the panel bus bar ratings. So it's just a complex thing that that the electricians and the solar guys all understand, but they're trying to not get in a situation where you could possibly turn on so many things and have all the, lots of power coming from the utility and the solar, and together the panel's trying to handle and distribute it all, and the panel gets too hot behind its faceplate.
I mean, in that case, wouldn't all the electricity coming from the solar go into the devices?
Yeah, it is, but
And-
there's, yeah, it is. And also, since we're doing counterflow, we're injecting the solar from the bottom and the utility from the top. Yeah, I think the code is ultra conservative, and this is just one of their ultra conservative things they've done.
So
But I kind of
so
agree with your intuition that it's hard to visualize the problem, but the way they describe the problem is they're not going to allow the panel to be sourced by more than 120% of its bus bar ratings. And then only when the sources come from opposite sides.
So-
You can't put them both from the top.
So from that rule, with a 200 amp panel, I could have 40 amps of solar.
Right. 40 amps of inverter output, which maybe is 50 amps of solar, because you can put more solar on your roof than your inverter can deliver. And the inverter then does what we call clipping. And so, for example, in this thing, I mentioned we're using a 5.8 kilowatt solar array, and we put it on a 4.3 kilowatt inverter. So there are a few sunny hours of the year when, right after you've cleaned the panels or something, when it tries, the panels want to produce 5 kilowatts and the inverter says, nope, I'm going to only deliver 4.3 out of here and not produce the other 0.7 kilowatts. So there's a few hours a year that get clipped by the inverter, but you get a lot more shoulder hours. And so the economics are good for putting in some more panels. And this is just because solar's gotten cheaper.
I have a friend that designs utility scale, and he said the inverters are typically 40% smaller than the nameplate of the panels, which that absolutely floored me.
Right. Yep.
Um,
All right. And then did we get to your
Yeah,
question?
I'll let someone else talk. I got a million questions, but thank
Okay.
you. Thank you.
We'll
Thank you
cycle
again for the
through.
wonderful presentation. Yeah.
Thank you. Yeah, we have a few other hands up. So let's go to Margarita. Margarita, I'll ask you to unmute.
Okay, I'm unmuted now.
Great.
I'm on my phone. So thank you so much, Tom. And I just have a comment. So we just upgraded our heat pump, our water heater, just this past weekend.
Yay.
Yes, it was wonderful. We went through Sunworks. They were fabulous. Ruben is a godsend. And if anyone's thinking of doing those things, and we also just upgraded our HVAC system in November, so we were able to take advantage of all the rebates of the Peninsula Clean Energy $10,000 loan. It was painless. We were the first people to go through.
Nice.
And so easy, and like as of right now, so we did 2 major projects that combined were probably about $20,000. And as of right now, we haven't paid anything because of all the rebates, and because they're still rolling out how to do the billing part of the loan, which is just going to go into our PG&E bill. So it's
Yep.
just so easy. So if anyone's thinking of doing it, and we didn't have that money just laying around for these 2 big projects, but all these incentives, everything was simple. And so, which is sometimes unheard of. So I just want to encourage people that if they want to do these projects, that they take them on. And our water heater probably had maybe just a couple more years left on it. So
Mhm.
if we were lucky, and so we were it was perfect. And my husband was able to help Ruben do with the installation. And I'm sure he's geeking out on your presentation right now. So
Yeah,
thank you.
that is thanks so much, Margarita. It's really fun to hear that adventure working out well and being easy. It's been a hard row for a lot of folks who went before you. And then I agree, boy, it's a lot of fun volunteering with Sunwork. And so that's something available to everyone here who's 16 years old and older. Is Sunwork is a nonprofit that helps train people how to do solar installations and heat pump water heater installations while really doing them. And so I got involved with Sunwork as a volunteer years ago, and I really like getting out in the field with Ruben and the other team leads and getting my hands dirty. And that's where I learned the do-it-yourself skills to do some of my home electrification myself. So thanks for sharing your story and giving me a chance to plug that nonprofit, sunwork.org.
Thanks, Tom and Margarita. All right, Jayanta.
All right, I've unmuted. So I have a very, very specific question, and I hope it's not completely out of place. We live in the Bellhaven neighborhood in Menlo Park, and as it turns out, we actually got our home as a solar built home built in 2007, unlike Ole's 100-year-old house. We are looking, to work with Harvest Thermal, which is, which some of you may be aware, and install a combined sort of hot water heater and heat inverter, a heat pump based heater to replace two of the three things in our house that are gas driven, which are the house heater and a tankless water heater. Now the question, so that's sort of the scenario. The question that I have is, as part of this change, we are going to need a tank for the heater. Right. And the way these houses were built, we have a 2-car garage that's just 20 feet by 20 feet, so it's really small. The tankless water heater obviously didn't need any space; it was built into the wall. And now we need to sort of go get a permit to install a water heater probably in our garage. And I don't know if you have any advice. Is that even possible?
Yes.
Given the fact that our our garage is so small?
Right. So I'm glad you asked this question. So I've been working with the city staff. Mr. Ori Paz on the staff is taking a look at the city's zoning regulations that define things like that 20 feet by 10 foot wide parking space requirement for new construction, and checking to see, can we reduce the conflict with electrification to allow people to place tanks that encroach into that 20 by 10 foot clear space. And so that matter is being looked into right now by city staff. They'll bring it to the Menlo Park's Environmental Quality Commission. They'll bring it to them in February. And so I recommend taking a look at the February agenda to see if it's on there, and then making a public comment about what you're doing in the situation and what you'd like. So the EQC can consider that. And then the EQC will make some recommendations, probably very pro-climate, and send those along to the Planning Commission, where the matter will be heard again. And then it will go to the council. So I think we do need to work on adjustments that should try to accommodate what you're looking for.
Thank you very much, Tom. That's very encouraging to hear. The other smaller question, if I do have time, and it's okay because others also have their hand raised. If you had any commentary about Harvest Thermal, if it's appropriate, I'd love to hear that if you or anybody else in the audience.
Yeah, so I really like the Harvest Thermal design, and I didn't feature them in this presentation, but I like it because it does that thing I'm always trying to do, which is save panel space. So they use one breaker, I think it's a 20 amp breaker, feeding about 16 amps to the outdoor compressor that looks kind of like this light, this tan box to the right. And then, like you said, it's got, it makes hot water, and the hot water then feeds their own brand of a fan coil box and controller. And it feeds a quiet tank somewhere in the house or garage. And then they get their hot water from the tank, and the tank also provides a little boost to the space heating. So I like that system. The thing that they're needing to look at different ways for people to get cooling service that they want. And so that's the one add-on that they've been having to evolve. And so I don't know where they are on that right now with your system. But one of the solutions, with that mentality I have, which is go ahead and do your electrification now, because some of these electrification things can be so modular. You can later add a window air conditioner for cooling, or a mini split heat pump, just one room, maybe the big room, that would do added heating and cooling. And so there are ways to retrofit cooling in after you do this as well. So anyway, you'll probably end up with your choice of whether to incorporate it into the Harvest Thermal system as another coil, or whether to do it as a separate add-on system.
Yeah, they have a night cooling module that they're using to sort of cool the house at night, not quite AC, but for our house, which has got good insulation, it might work out. We haven't had AC for about 15 years, and hopefully we can live without AC.
Yep. All right, thanks.
All right, let's go over to Aurora.
Thanks, Nancy. Thanks for facilitating, and thanks for all the lessons learned and great information, Tom. I just have a quick question. You alluded to some webinars where you obtained information on the Fed IRA. Can you recommend any resources where we can keep up to date on what's happening with that? And
one place to look would be Rewiring America. And so Google Rewiring America IRA, and they probably have, their calculator up, and you can populate their calculator with things like your family size and income and zip code, and then it kind of calculates what incentives apply to that situation. So that's the first one I'd recommend. But I also know that some of the agencies are right now going through rulemaking as well. So maybe when we're probably going to try to put together a follow-up document with some links that for questions that come up in this. So maybe I can try to find one for how to follow the federal policy, if that's something you like.
that would be wonderful. Thank you, Tom.
All right, thanks, Aurora. Let's go to Irene.
Hi, thank you both for doing the presentation. So we have, I think, somewhat of a unique situation. We have a 90 amp fuse box with 2 sub panels, and we're looking to electrify. We have a gas water heater, gas furnace, coil cooktop, and electric oven, electric microwave. So we want to install solar to offset 100% of our electricity needs, which is about it's about 1,000 watts per month with an EV. So we got some calculations done from a couple of solar installers, and they're telling us that we need 14 kilowatts of panels and 2 Powerwall battery to store the electricity. So the question is, can we can we still go with a 100-amp panel with the way that, you know, you have your panel design organized? Or should we just
I don't think
make the
so.
investment and go with the 200?
Yeah, I think, you know, the size solar system you're up to is well over the 100-amp panels limit. I was showing earlier, it's about to land solar onto a 100-amp panel, you top out at around 5.8 kilowatts. And the firm you're talking to is looking at a size almost 3 times that big. So I think you'd probably be up to a 200-amp panel.
So the 5 kilowatts that you're referring to, I'm assuming, since it's about a third of the size, I'm assuming it'll just give us about 300 to 400.
Kilowatt hours per month. Is that?
Yeah, about 350
Mhm.
kilowatt hours per month. So we would need to go with a 200 amp to utilize like 100%, to offset 100%.
Yeah, well, I mean, I don't know, or I can't do it this all in my head, and I don't want to be the concierge, but your solar contractor is probably pretty good at doing this calculation.
Well, the
And then-
other thing, the other thing is that we're currently basing the electric usage off of like electric off of very old appliances.
Mhm. Oh yeah, that's a good question. You know, one thing to look at, maybe in the links, that tool I showed that is called Zero Carbon Home from Josie Gaylord and her son. I think that one would let you put in kind of before and after appliances. And that would help see whether you get some advantage from more efficient appliances.
That would be great, because right now we can't size what we need, because what we're using is not what we will use.
Mhm.
Thank
Right.
you.
Yep, you're welcome. But I think, yeah, I think her tool will help do that. Let me just go back to the slide that had those links. In case anyone wants to.
And we'll send out all those links to you,
Yep.
right, Tom?
Right.
I think
So her
earlier,
tool's that bottom right link.
thank
Okay.
you for that.
Thank you.
Before we go to the next hand, Marlon, I'm wondering if you could share the link again for everyone to let us know what topics they want to hear again. And then there's a place where you can add your email address, and then we will make sure that you get all the resources later. All right, I think our next hand is Trisha.
Great, thank you. Yeah, and I'd also put my question in the chat. I wanted to find out more. So we're kind of starting on this journey other than having an EV, and wanted to find out about starting with solar panels only versus starting with solar plus a battery, and some of what we should be thinking through on the pros and cons of that.
Yeah. So it sounds like you're trying to decide right now whether to go start by getting solar or start by getting solar and a battery.
Correct.
Okay.
So, I mean, yeah, we
Yep.
want to get solar in time for the NEM 2.0 is what we
Yep.
understand is important. And then we're just trying to figure out, do we start with just the panels, which is what we're talking
Okay.
to one company about, or panels and a battery?
I see. Good questions. Yeah, so my understanding of the NEM 3 transition away from NEM 2 is that you have up to April 13th, not tax day, it's before that, April 13th to execute contracts for solar that would then qualify for treatment under NEM 2. Net energy metering is what NEM stands for. And that's more lucrative treatment. And so people are trying to meet that. And then you can have your solar contractor, I think they can design and install a system that's battery ready. And in case there's any supply shortfall on batteries or something like that, but under this transition to NEM 3, those contracts executed between, anytime before April 13th, you and the contractor have up to 3 years to do the installation and still get NEM 2. So that's kind of interesting. You don't have to finish the installation in April. You just have to have a signed contract.
Okay,
That's
and up to
my
3
understanding.
years. I didn't know that time frame. And then what do you think about starting with solar only versus solar and a battery?
I think that's probably what I would do, because I'm kind of a go slow kind of guy, and my power is fairly reliable, so I'm not too worried. And I've got a 2-burner Coleman camp stove in case it ever does go out. I could still make coffee, so I'm not too worried.
Okay, great. And then when you say battery ready, meaning that the system that they put in, we could install a battery at a later date? Because I've heard
Right.
sometimes that if you don't have a battery installed, a company doesn't want to come back and put one in later. So making sure that that's contractually in there.
Yeah,
Okay.
that makes sense. And especially if you're dealing with a company that installs both solar and batteries, they probably could design that easily for you, assuming they would accommodate their own battery soon after. But one thing to be careful of is, these technologies are advancing and moving along, and so are requirements. And so that may be what they worry about, is what if they put the solar in this year and you waited 5 years, and now the way those, what are those 2028 batteries are, it doesn't relate to the way 2023 solar was.
Yep.
Yeah,
Okay.
so I wouldn't wait too long. But that's just my naive view of it. I'm not an electrical engineer. I'm just a mechanical.
Okay, thank you. And
You're
thanks for
welcome.
the presentation.
All right, we're just past 8:30, but there's one more hand up. Are you good with taking one more question,
Oh,
Tom?
definitely. Yep.
Okay, Coca, back to you.
Hey, Tom, thanks a lot. So I just wanted to say, Irene was asking about, having an oversized solar system. And I think I had that on my home, and my contractor bypassed the panel and just plugged right into the main. And he put a different circuit breaker on there. And
Right.
I think that's fine.
Yep.
what
Yeah.
do
So,
you think?
right. Thanks for reminding me. So that's called a line side tap. And so that's possible. It's relatively easy if the panel is separated from the meter, but in modern panel setups, often they've integrated the meter socket into the panel, and there's not an easy way to access the feeder between the meter and the bus bar. But when they are separate, it's easy to do a line side tap into that.
And someone with a 90 amp panel might have that separated.
Right. 90 amp fuse box, you said. So
Fuse
she
box.
may have that good separation and an easy way to get in between. Yeah, so maybe that's why they had that aggressive solar sizing at 14 kilowatts.
Just want to say hi to Trisha. Haven't seen you in the pool lately. It's good to see you.
Right, and I see there's 2 more questions, so I
Great.
don't mind staying on if people want to.
All right, back to Irene then.
So about the 90 amp, we were told by, and one of the companies was Sunrun, was the installer. They told us that we would need the 200 amp. They basically said you need to get rid of your 90 amp fuse box, and we would need to upgrade you to the 200 amp. So I'm not sure how going to the direct line or how that would all work. I'm not versed in any kind of wiring.
Yeah. Yeah, and I've not seen it, but if if they're telling you that, you may shop around and get another quote and try to explore it with the next quoter to see if what that contractor says. Maybe they can help educate you. And it's certainly very possible that Sunrun had it exactly right, and that there's a reason you need that. So, I'd say just talk to another one and improve your data. But one more thing I wanted to mention about all this panel efficiency I talk about, or another name for it is watt diet. Even if you end up with a 200 amp panel, it still helps society out if we can choose right-sized equipment for our furnace, our water heater, etc., and not oversize it, because then more of our neighbors can electrify. We don't have to upsize everything in the whole Western US to meet our energy needs. So it's really, my encouragement is to pick the most efficient equipment you can find and the most power efficient. So energy efficient and power efficient, and they're pretty well related. And then controls help, but I'm thinking we'll be able to electrify a lot more people if people electrify simply.
Yeah, so the chart and the diagram of that panel is just, it's really well designed.
Yeah.
There's so much put in there, and it's like a Tetris puzzle.
Yep. Yeah, and that's, I had been doing these things in spreadsheets, and then Josie was sharing them in one of her groups, and an architect was taking a look at the spreadsheets and saying, why don't you convert the spreadsheets to something that looks a little more real? And so that's where the panel design came through.
Yeah. So I actually have a second question, or
Sure.
third question, about the solar installation. So our roof is about 12 to 14 years old. It's a composite roof. There are some small areas that we were told that needs sealing or minor repairs, but I'm assuming that it's not something that even if the roof only lasts 25 years, we're at the halfway mark. If we're at the halfway mark, we're not, we can't seem to decide, should we install solar now or wait, or should we just get it installed, pay the extra labor to have it removed, to have it taken off, and then pay the extra labor to have it put back on when a new roof is needed?
Mm-hmm. Yeah, good questions. And then there's also one more option, which is sometimes we're just putting solar on one plane of the roof. And so you could re-roof that one plane and not re-roof the 2 or 3 other surfaces of the roof.
Mm-hmm.
And put the solar on it. And so then you have a small solar job and a brand new roof under solar, and you're ready for 30 or more years. The other thing I notice is these composite shingle roofs can last quite a while too. So, I think they can outlast their rating. So that's another thing. And then a third thing, for somebody who came right up to the wire with that 3-year limit on contract or on installations after they signed a contract before April 13th, et cetera, and they were coming down to it, they might want to just go ahead and put the solar on the old roof, because the lucrative advantage of NEM 2 was so big it would pay for the removal and replacement of the roof.
That's what we were told,
Mm-hmm.
to take advantage of that and just pay the labor.
Right, but do check into that thing that I'm mentioning that I've heard from my solar contractor friend, that they just have to execute the contract by April 13th, and they have up to 3 years to install the system.
Correct. Yes. We just need, they just need to finish the paperwork. Thank you.
Yep.
All right.
welcome.
Hey, Tom, there was a question in the chat
Yeah.
that didn't get discussed here. It's from Peter. He says, I didn't hear mention of water heating by direct solar radiation of a roof mounted tank. Is such a system now out of date, too inefficient, or some other reason to avoid it?
Right. So I didn't mention it because I was mostly talking about electrification. And so, the thing that he's raising is passive solar water heating by having a black tank in a box with a glass cover, and the sun shines through the glass and hits the black tank and directly heats the water. That kind of water heater actually became popular in Southern California 100 years ago. And then a company started insulating the box around their tank, and they had the name Day and Night, and there still is an appliance company, that's their company, Day and Night Water Heaters. So that's a water heating technology that does provide part of the heat needed for Western standard living water heating. Typically, I was a solar engineer for a while on those kind of systems, and they do well in the summer and they don't do so well in the winter. So you still need some form of backup heating, and you could feed that partially solar heated water into a heat pump water heater that would finish it off. I tend to think now of our clean electric grid, where Peninsula Clean Energy is putting in more solar. As I put in more load on my house, that raises how much electricity they have to go procure. And so they go procure more solar. So my heat pump water heater is dry solar water heating. So without putting plumbing on the roof, I end up with a heat pump water heater with solar heated water. It's just indirectly via heat pump and solar electricity.
All right. Thanks, Tom. Let's see. There's other questions. Let's see.
Excuse me, this is Peter. Supplementary question to Tom. Any comments about the efficiency of this direct radiation heating of water, which you just were talking about?
Yeah, I'm trying to remember. So they were pretty efficient at soaking it up, but then they had the problem of losing it back again through the glass and through the rest of the box. My gut feeling was they were around 30 or 40% efficient at their utilization of sunshine. So they were fairly small and could use 30% or so of the energy of the sun to heat the water. That might be enough to produce half of the water heating energy you needed. Some people confuse that 50% with efficiency. But yeah, anyway, so those systems are somewhat efficient. And what we found with photovoltaics, the solar electric, is it's actually a lot cheaper to install solar electric, because you don't have to run plumbing to the roof and insulate the plumbing and run and keep it all from freezing and things like that. So really, I haven't seen too much activity in direct solar thermal water heating much in the Western US. I think our labor costs are too high.
Thank you.
All right. There are some comments in the chat, ideas about solar water heating for Menlo Park's pools in Bellhaven, as well as at Burgess. And then there was another question. Wait, did it just get asked? Was there an opinion about a combo solar and wind energy power generator?
Yeah, I don't have any real thoughts on those.
Okay. That was from Jayanta. Jayanta, did you have anything else you wanted to say? I see your hand raised.
No, that was my question. You got it. Thank you.
Okay. Cool. Well, does it feel like we're at a close, Tom, here?
Yeah, I think if people don't want to raise any more hands, and hopefully folks have been taking care of each other in the meeting chat.
Yes, the chat has been quite active.
Excellent.
And requests for having, so we've recorded this and we'll put it up on the website, which I will send. And I'll drop again the link where you can add your email address and tell us what else you'd like to hear about for future. And then we'll just make sure we're all connected and that you all have the resources you need going forward.
All right. And then are you able to save the chat?
I am able to save the chat,
All right.
which I don't think I'd share with everyone, but we can mine it for things that are useful.
See if there's other points we want to address. Okay.
Yeah, for sure. All right. Well, thank you everyone for coming. And Tom, thank you for that amazing presentation.
Right.
I don't know if you saw, there was like a lot of kudos going out to you. This was so informative. And I think we're just so lucky to have you as an expert in our community, and your generosity and willing to share your expertise is.
Well, thanks so much. I feel lucky to be here and really enjoy the engaged community, looking at how we can tackle this big problem, you know, and I think it can be quite satisfying. I think we need to go into it head first.
Indeed. Well, thanks everyone. Take care and have a great evening.
Thank you. Good night.